Alright, so what it is, guys, my name is MathManKidBoy765304.2, and okay, so solving trig equations sounds pretty interesting. Let's take a look. We got some trig identities here. We're gonna be using these later, but first let's just take a look at what we've got set out for us. So first step is gonna be simplify with trig identities or just algebra. The second step is gonna be your unit circle. And your third step is going to be check your answers. Okay, so sin x plus 4 equals 5. Whoa! What is this? Oh, well, it's actually pretty simple. Actually, you just subtract 4 from both sides, and you get sin x equals 1. But where does sin x equal 1? On the unit circle here? It's right here. Okay, so you know how sine is the y in the x comma y thing? Yeah, so sine is here, 1. That means it's 90 degrees. And look at that, x equals 90 degrees. 2 times sine x minus cosecant x equals 1. That is a little bit harder, so you're going to have to use some, some sine trigonomic or whatever identities. So, yeah, so you use these to figure out that cosecant equals 1 over sine. So, I don't know where that is. Oh, here we are. So sine equals 1 over cosecant. So yeah, so if you didn't know that, then that's pretty much is right there. So, and then moving on, you realize that so you can just multiply both sides by sine of x, and that'll give you 2 times sine squared x here, and then minus 1 because this x cancels out, and equals sine x. And then you got this, which is obviously a quadratic equation or whatever. You know, you factor it up, and then you get sine x equals negative 1/2 and sine x equals 1. Pretty simple. Now, where does sine x equal negative 1/2? Oh, here we go. We got 210 degrees right here, negative 1/2. And where else do we got? Oh, and we got 330 degrees. So we got 210, 330. And then what about sin x equals 1? Well, that would be, again, 90 degrees, and that'd give us our 3 answers. Alright, so here stuff gets a little harder, so I'm going to bring in my much smarter associate to do this one because I'm not smart enough to do it, and it's, hard and stuff. Alright guys, so we're going to be doing the hard question now, so here we go. Let's just start this right off. Alright, so we got square root of 3 cosine squared x minus sine 2x equals negative sine x. Now what do you do here? Well, you're going to want to get rid of the square root. You square both sides, and that makes it 3 cosine squared x, blah blah blah, sine squared x, so because the negative goes away. Alright, and then we move on. Basically what you do is you take this cosine squared x, so you make cosine squared x equals 1 minus sine squared x, and then you factor in the 3, which makes this negative 3, and you add that over, and that's 4 sine squared x, and this is plussed over, and this is subtracted over, so you get all this big nice thing. Then what you do is you replace sine squared x with 1 minus cosine 2 over 2, which is insane because it's the half angle formula. So right here, you don't want this piece of trash, you want this piece of trash. So you're going to go 1 minus cosine 2 over 2. So now that you've got 1 minus cosine 2 over 2, well, you still got a 4 over here, so you can just divide 2 over 4 and you get 2, so that's how that happens. And then you multiply this back in and simplify it down to this, move everything to the other side, making this a positive, this a negative, and this a positive. And then what you do is some crazy, you take this 1, and you know that that's sine squared plus cosine squared, that's a pretty obvious one. Then got this sine 2, and that's a double angle. Now what is a double angle? So basically it's sine 2, well that's going to change into 2 sine times cosine because of some weird rules that nobody understands. This turns into negative 2 sine cosine, and then this, use the other double angle formula for this one, which is cosine 2 equals cosine squared minus sine squared, and you multiply that by 2 because it has a 2, and then you distribute everything in, you simplify it down, and then you get this, and then what you do is you realize that, wait a minute, negative 2, well that's just negative 3 plus 1. So obviously negative 3 sine cosine plus 1 sine cosine is going to equal this, because it's, it's obvious, right? And then you factor this 3 cosine out of this side and 1 sine out of this side, and you get 2 cosine minus sines. You see that? These two? Yeah, so you get 2 of those, and then you can do this weird crap with the, multiply them together or whatever. And then you've got 2 different equations, and then you can easily find out that if you divide by cosine here, then it's going to give you 1. If you divide by cosine here, then it's going to give you tangent. And if you divide by cosine here, it's going to give you the same thing, except it's going to be a 3. So you can subtract this over, tan x equals negative 3, add this over, tan x equals 1, and you realize, wait a minute, negative 3 is not on the unit circle. I mean, come on, that's obvious. So then you have to figure out where tan x equals 1, and tan x equals 1 here, because rad 2 over 2 divided by rad 2 over 2, it's 1. That's 45 degrees. And then here it's the same thing, except they're negative, so that's 225 degrees, and you get 45 and 225. Thank you for listening. This has been... what's my name again? MathManKidBoy765304.2. Goodbye. Right, so now we're going to be doing the graphing the sine function, because that's the next step of it. And so this is the formula for the function or whatever, and this is supposed to be times, but it kind of made the stupid little line under it, and that just looked like absolute garbage, so I had to remove that immediately. So this is a sinusoidal whatever. What does A do? That's the real question here. So what does A do to this problem? Well, A, if it's a larger one, it will make the height go higher, which is the amplitude. And if it's smaller, it'll make the height go smaller, and this is the normal one. So what does B do now? Now this one's a little tricky. So the smaller it is, actually the longer it gets, and that's because the period is actually what's being changed. So 2 pi divided by 1/2, well, that's going to be a bigger number than 2 pi divided by 2. So 1/2 is going to be bigger than 2. Say indeed just move the function up, down, left, or right, or whatever. And now let's just do one of those problems. So y equals 1/2 times 12x plus 2 minus 5. A is 1/2, obviously. B is going to be 12, but you got to put that in the period, thing. So 2 times pi divided by 12. That's going to make it pi over 6 is the period. And then C equals -2, because basically, how this function was negative here. Well, now it's positive, so this must be a negative. It's amazing, truly just amazing. And this is basically what it makes, and it's really interesting because it's a bunch of lines, and yeah.